Welcome to part 1 on the unit circle. Most of you know what a unit circle looks like, and you could probably even draw one on your own without looking at this picture. The unit circle is defined as the circle with a radius of unit length 1, centered at the origin in the xy plane. Its equation can be written as x squared plus y squared equals 1. If we were to look at the quadrants of an xy plane, you might recall that the first quadrant is in the top right corner, the second quadrant is in the top left corner, and we work our way around counterclockwise. So the third quadrant is in the bottom left corner, and the fourth quadrant is in the bottom right corner. If we were to look at the signs for these quadrants, respectively, we would have positive, positive in the first quadrant, negative, positive in the second quadrant, negative, negative in the third quadrant, and positive, negative in the fourth quadrant. If you still are kind of wrapping your mind around this idea, it would be a good idea to maybe sketch this out a few times and make sure you can keep track of where the signs are positive and negative. So now let's look at something that seems completely unrelated. A triangle has 3 angles and 3 sides. If we wanted to solve a triangle, it just means to determine all of its parts with the given information. So we'd find all the sides and all the angles. So let's take a look at the following equilateral triangle of side 1. If we wanted to draw one of the heights, we know the sides of this equilateral triangle are stated to be 1. If we were to split this into 2 down the center, we would have 2 right triangles. We also know that if all the sides are the same, then all the angles on the inside will also be the same. So this equilateral triangle would have 60-degree angles all the way around. So if I were to split the top into 2 equal pieces, I'd have 30 degrees and 30 degrees, which would add to 60. So 3 times 6 is 18, or 180 degrees. If I wanted to figure out what one side of this triangle would be, and I'll go ahead and highlight it. Let's say I wanted to figure out what this height would be of one of these right triangles. I'm just going to break it off here on the side and sketch it again, approximately freehand. Half of one side, which means I have a side that is 1/2. I have a 1 for the hypotenuse, and we don't know what this side is. But I do know that this angle here is 30 degrees. That's the acute angle. I know that this angle to the right is 60 degrees. And the other is 90. So again, the angles add up to 180 degrees, and I know 2 sides of the triangle. I also remember that a squared plus b squared equals c squared, and c squared is 1 squared because this is my hypotenuse, the 1 here. That's my hypotenuse. So I'll have 1/2 squared plus question mark squared equals 1 squared. Now if I were to show you where each one of these is. My half is coming from one of my sides. The other unknown amount here is my other side, and 1 squared is my hypotenuse. So I'll have 1/4 plus some unknown amount. We'll just keep calling it b squared until we figure out what it is, equals 1, because 1 squared is 1. If I subtract 1/4 from both sides, I get b squared is equal to 3/4. If I take the square root of both sides, I get b is equal to the square root of 3/2. Notice that the square root of 3 doesn't simplify, but the square root of 4 does. This may seem useless at the moment, but trust me, it will become very helpful and convenient very soon. So b is equal to the square root of 3/2. So we now have the inside height of this triangle to be the square root of 3/2. That's our height. So now we're going to do something similar with this square. If we consider the following square, we can draw a triangle by drawing a diagonal line, which will create two similar right triangles. If we suppose the diagonal is 1 unit, we can solve the triangle. So let's do that. I know that the diagonal is listed as 1. And I know this is a 90-degree angle. And I know these two angles, the other remaining angles, are 90 divided by 2, or 45 degrees. If the diagonal is a unit of 1, we need to figure out what the two sides of this triangle is. So we can use the fact that A and B equal each other. So that means if you have a squared plus b squared equals 1 squared, and we know that a equals b, then if we just replace one with the other, we'll have a squared plus a squared, because they're equivalent lengths, equals 1. This means that 2a squared equals 1, and a squared equals 1/2. If I take the square root of both sides, I get a is equal to plus or minus the square root of 1/2. If you rationalize this by multiplying by 2/2, then you would get the square root of 2/2. And this defines a side. So I'm only going to keep the positive because we're looking at lengths here. So I have a side square root of 2/2. That means that b is also root 2/2. And again, this will be very convenient when we move on to the next page. When we're looking at the unit circle, the intersection of the terminal side of an angle in standard position and the unit circle is called the terminal point. So if we were to look at this graph here, it's a very large circle so that you have plenty of room to draw on it. But if we wanted to divide this unit circle into special angles, 30, 45, and 60, and find their terminal points, we could do that with the information from the previous page. Now, it's important to note that I can break this right first quadrant into a 45-degree angle, And then from there, I can also break it up into a 30-degree angle. So the 30-degree angle is the smaller one. Then 45 will be the next one. And then after that, we'll have 60. And these are kind of hard to draw all over each other, but if we call this one 60 degrees here, it's the largest of the three in the first quadrant. We have these terminal points along the edge of our unit circle, and we can label them. So we know that the first one will have a larger x coordinate than it would y coordinate, because if you look at this, it's actually way larger horizontally than it is vertically for this coordinate point here. So we would say this is the square root of 3 over 2. And the second point is 1/2. So it's moving over root 3 over 2 and up 1/2. For 45 degrees, we would have an x and a y coordinate that are equivalent. Root 2 over 2, comma, root 2 over 2. And the last one here is actually going to be a swap of x and y from the first coordinate point. It's going to be 1/2 in the x direction and root 3 over 2 in the y direction. If you look at this, you can see how if you memorize the first quadrant, everything will just be a reflection in all the other quadrants. The signs will just change. It's so convenient. So if you memorize the first quadrant, the other quadrants will fall into place. And now I would take some time to fill in the rest of the quadrant and double check your work. This is something you absolutely should memorize and not just derive every single time you need this information.